Okay, so here is Newton's third law. We skipped this because Newton's second law is the mathematical law. We're going to have to do a lot more discussion with that. And plus, third law is pretty quick. It's a simple law to learn. I like to call it his golden rule. Okay, because this oftentimes will apply to life as well as just simply physics. So the amazing thing about forces is that they exist in nature as pairs. Okay. Remember, you have to have two objects that interact for forces to exist. So remember, the word interactions means that you have to have two things affecting each other, right? And so his third law, so Newton's third law of motion states for every action force, there is an equal but opposite, sorry, I forgot the word. So there is an equal but opposite reaction force. Okay. And so this is, I'm sure you guys have heard from parents and guardians saying that for every action is an equal but opposite reaction. Okay. That's why I call it the golden rule, okay? Because when you leave out the word force, it becomes the life lesson. But when you put the word force in there, it now becomes the Newton's third law lesson, okay? So these forces, what we call them, are action-reaction pairs. Okay? And so what happens is, for example, if I'm pushing on a wall, well, by definition, the wall is going to push back on me. Okay, so if I exert a force on the wall exerts a force on me. Okay, much like, you know, if the Earth exerts a force on a falling object, the falling object exerts a force on the Earth. Okay. That one just seems like a little weird, because in the sense that how can something that's falling less massive than the Earth affect the Earth? It does, just you don't really see it. Okay. Now, if I write this in kind of symbol format, so if I do force of me on the wall, that's going to be equal to negative wall of the force of the wall on me. Okay. And so, yes, this has to be negative because it is going to be equal in magnitude, right? But opposite in direction. That's what we're saying here when we talk about equal but opposite reaction force. So the equal part comes from the magnitude, right? Okay, and then the opposite comes from, now this will have a negative sign. Now, sometimes people think that, oh, they're just going to end up canceling out, right? Now, in the grand scheme of things, yes, they do cancel. But one thing is that they're not going to cancel here because the forces act on each other's system. So if you remember the idea of systems, right? And so if I just draw a quick little picture here, here's my hand, right? I'm pushing on the wall, okay? And then, of course, we know by Newton's third law, the wall has to push back on me. Okay, so this is F wall, this is F me, okay? But the difference is my force, right? So if we circle the systems, right? There's one system, right? My hand. And what's the other system? Well, it's going to be the wall. So note that my force is going in is the external force to the wall system, and the wall's force is the external force to my system. So granted, yeah, in the grand scheme of things, you know, kind of, you want to talk about the grand scheme of the universe, yes, they will ultimately cancel out. However, But if I'm treating them as second or third law action-reaction pairs, they're not going to cancel out because I've got my system and then I have the wall system. Now, if I treat them as one big system, the two forces now become internal, which means we don't have to worry about them anymore. Okay, we don't have to see how they affect each other. Okay, but because in the way I have the picture drawn, they're external, they will affect each other's system. Okay, so now in the next video, we're going to talk about second law. So we're now going to start taking these more conceptual based ideas and turning them into a mathematical process.